The equilibrium constant of a reversible chemical reaction is defined by a fraction. The equilibrium concentrations of the products are the numerators. The equilibrium concentrations of the reactants are the denominators. Each concentration has a power term. The power term is equal to the coefficient of the corresponding chemical in the balanced chemical equation. The square bracket represents the equilibrium concentration of the corresponding chemical. Experiments show that for any given chemical reaction at a given temperature, the value of this fraction is a constant. Since we use the equilibrium values in this fraction, we call this constant equilibrium constant. If we use the equilibrium concentrations of the products and the equilibrium concentrations of the reactants, we call this equilibrium constant Kc. For chemical reactions that involves gases, we can also use the pressures of the products and the pressures of the reactants in the equilibrium constant expression. In this case, we call this equilibrium constant Kp. For any given chemical reaction at a given temperature, the value of Kc is a constant. The value of Kp is also a constant. But even for the same chemical reaction, the value of Kc may be different than the value of Kp. For different chemical reactions at the same temperature, the values of Kc's may be different, and the values of Kp's may be different as well. The equilibrium constant expression does not include the liquid or solid for a heterogeneous reaction. Let's look at two examples. Example number 1. A and B are reactants, C and D are products. A is a solid, D is a liquid. Both B and C are in gas phase. Therefore, the equilibrium constant expression of this reaction is defined as the equilibrium concentration of C to the gamma power divided by the equilibrium concentration of B to the beta power. The equilibrium constant expression does not include A or D. Example number 2. A and B are reactants, C and D are products. B is a liquid, C is a solid. Both A and D are in aqueous phase. Therefore, the equilibrium constant expression Kc of this reaction is defined as the equilibrium concentration of D to the delta power divided by the equilibrium concentration of A to the alpha power. The equilibrium constant expression Kc does not include B or C.